So how does an AI read a 100-page document and connect some tiny, crucial detail on page 1 to a penalty clause way over on page 98? It all comes down to a question of memory. Today, we're going to dig into why some AI models are basically designed to forget, while a revolutionary approach called attention lets others remember absolutely everything all at once.
All right, here's how we're going to break this down. First, we'll set up a classic memory problem. Then, we'll look at two totally different ways AI tries to solve it. One that reads step by step, and another that sees everything at once. And finally, we'll reveal exactly why one of these methods is the reason AI can handle such massive amounts of information today.
Okay, let's kick things off with a problem of memory. Now, this is a challenge that seems pretty simple for you and me, but for a very long time, it was a huge roadblock for artificial intelligence.
So I want you to imagine an AI trying to make sense of a 100-page legal document. You know, it's not enough to just read the words. The AI has to actually connect ideas that might be separated by dozens and dozens of pages to get the full picture. For instance, let's say a really critical interest rate is defined right on page 1, but the penalty clause that completely depends on that rate, well, that doesn't show up until page 98. To really understand the risk involved, the AI has to connect those two very distant points. It has to remember.
And historically, this exact kind of long-distance connection is precisely where older AI models would just completely fail. We've seen it happen. So let's take a look at the first approach to this problem and see exactly why it struggles so much.
And that brings us to our first method, sequential processing. Think of it like reading a story one single word at a time. As we're about to see, this kind of linear approach creates a fundamental built-in memory problem.
This approach, which you see in models called recurrent neural networks, or RNNs, is a lot like someone reading a book one page at a time. With each new page they turn, they update this little running summary in their head of what they've just read. But here's the kicker. That summary, its active memory, is incredibly small.
So you can guess what happens, right? As the model reads from page 2 to page 3 and all the way to page 50, new information is constantly coming in and just overriding the old stuff. By the time it finally gets to that penalty clause on page 98, that critical interest rate from page 1, poof, it's gone, completely washed away by this flood of new data.
Now, this isn't just a metaphor for forgetting. It has a real technical name, the vanishing gradient problem. It's a core mathematical limitation that makes it nearly impossible for these kinds of models to connect information across really long distances.
And this is the most crucial point to get. The system isn't being lazy, it's not making a mistake. This is a fundamental constraint of its architecture. That little active memory window literally has no room to store every single detail from the beginning. You could almost say it's built to forget.
But what if the AI didn't have to read page by page? What if it could just see the entire document all at once? Well, this is where a revolutionary architecture called the transformer comes in and completely changes the game.
Meet the transformer. Instead of that one-way timeline, I want you to picture laying all 100 pages out on a giant table. The model can see every single word from start to finish at the exact same time. This is parallel processing, not sequential. Now, the magic trick here is called self-attention. Here's how it works. When the model looks at the word penalty on page 98, it doesn't just look at the words right next to it. No way. It directly compares penalty to every other word in the entire document, and that includes interest rate way back on page 1. It then calculates a relevant score for every single pair, creating a direct, powerful connection between them.
And here is the absolute key. Nothing ever fades away. The information from page 1 is always available. Every single time the model processes the document, it rebuilds this entire map of relevance completely from scratch. That means no long-distance connection is ever lost.
So let's put these two approaches side by side. I think seeing them head-to-head makes the difference absolutely clear.
So on the left, you've got the RNN, just trudging along step by step, its memory fading with every inch of distance. The path to connect two words just gets longer and longer. But on the right, you have the transformer. It processes everything in parallel, and the path length to connect any two words is always constant. It's just one direct step, no matter how far apart they are.
And you can see that core split in their design right here. The RNN is sequential, and its ability to connect things is totally dependent on distance. The further apart things are, the harder they are to connect. The transformer, though, is parallel and completely distance independent. It can connect any two words instantly. It's a total paradigm shift.
Okay, let's lock in the final, most important takeaway here. Why does this huge difference in architecture matter so much for the AI that you and I use every single day?
Well, the first system, the RNN, has a memory that is fundamentally short-term. By design, it can only carry the most recent context that it's seen.
And because of that sequential design, information from the past doesn't just get ignored. It fades away and is permanently lost. Once that detail from page 1 gets overwritten, it's gone for good. There's no getting it back.
The transformer, on the other hand, never permanently loses a thing. Instead, it's constantly rebuilding its understanding from the ground up, reevaluating the relevance of every single piece of information to every other piece.
And this is the core difference. With attention, information isn't lost, it's just reweighted. That interest rate from page 1 is always available. Its importance just gets turned up or down depending on whatever the model is focused on at that moment.
And disability, to maintain access to the entire context without ever forgetting. That is the superpower that allows transformers to understand complex legal documents, to write thousands of lines of code, and to power the entire AI revolution we're all living through. This is why attention scales.